Our project title is Unsupervised Knowledge Graph Generation using Semantic Similarity Matching. A knowledge graph is a direct multi-relational graph and a collection of interlinked descriptions of entity-relation-entity with nodes representing a real-world object or a concept and edges representing the relationships between nodes. There are some key problems in building a KG. For example, supervised or semi-supervised methods require large amounts of annotated data. Some existing unsupervised methods generate too many redundant triples or require manual mapping to a known relation schema. Therefore, we propose an unsupervised method to build a KG with four major components. The first component is entity extraction. We first use coreference resolution to identify different expressions of the same entity from the text. Here is an example. The pronoun he in the sentence will be replaced by Obama. The next step is name entity extraction. A name entity refers to a real-world object associated with a name. Here is an example. We use an NLP tool, Spacey, to detect Barack Obama as a person, and Hawaii as a location and Harvard Law School as an organization. The second component is entity tuple formation and filtering. The first step is to use permutation of each identified entity to form a set of entity tuples. Here is an example. Given Barack Obama, Hawaii, and Harvard Law School as identified entities, we now have 6 entity tuples. The second step is entity tuple filtering. We apply the following field rules to filter out some unpromising entity tuples. Rule 1 is head entity must be a person, location, or organization. Rule 2 is if head entity is a location, the tail entity must also be a location. Rule 3 is the position of head entity must be less than the position of tail entity. Here is the result. We will have 2 tuples as the candidates for the next step. The third component is relation extraction. We first construct a substring starting from the head entity to the tail entity. We then use the head entity and tail entity and the predefined set of relations to construct a list of strings. Now we use sentence BER, which is an embedding model, and we use cosine similarity to calculate the similarity between the string from the left-hand side and each string from the right-hand side. And then we pick up the highest score returned as the final result, but we set up a threshold 0.8. If the highest score returned is less than 0.8, we will discard the return result. So in this example, we have birthplace as the relation between Barack Obama and Hawaii. The last component is knowledge graph storage and visualizing. We use Neo4j graph database to store the extracted triples. This is necessary for the downstream tests such as the Q&A system. Here is an example of our interactive system. After inputting text, the user can have an option to select their predefined relation schema. And they can also choose non-faces as the potential entity. After submission, we can see the graph from the right-hand side, and the user can move nodes around to have a better visualization. For evaluation, we use our system on 3 different datasets and compare with 2 state-of-the-art models. One is Stanford OpenIE and the other is MAMA. From the result, we can see that our system outperformed the 2 other models. In terms of precision, we call an F1. In conclusion, we present an unsupervised system for KG generation. A novel feature of the system is that it uses semantic similarity matching to extract relations between entities. Our system outperformed 2 state-of-the-art unsupervised models over 3 different datasets, and we developed an interactive KG generation and visualization tool. Thank you.